All right, this is going to be a really brief video lesson on calculating something called percent ionization. So what we know is that our strong acids completely ionize. So they ionize 100% into ions. So they break apart 100% into their ions. We also know that our weak acids do not completely ionize. So they have something called percent ionization to describe how much they actually ionize or break apart into ions in a solution. So to do this lesson, would like to have a copy of this handout. If you don't have it, not a big deal. It's not very long. You could write it all out. So just remembering that our weak acids, they partially ionize, whereas our weak bases, they have a weak attraction for protons. So to calculate percent ionization, we look at this formula. Percent ionization equals concentration of the acid that has ionized divided by the concentration of the acid solution times 100%. So exactly the same way we would calculate percent for anything else. In short form, it looks like this. P equals hydrogen ion concentration divided by HA concentration. So this HA really means the acid solution, because remember it's that H plus the acid times 100%. And if we rearrange that, we can get a formula for hydrogen ion concentration. So our hydrogen ion concentration is going to equal percent ionized divided by 100 times the concentration of the acid. So in our first example, and our only example we're going to do in this lesson, we're going to calculate percent ionization of 0.10 mole per liter of methanoic acid, which we have the formula for 8 right here, if the pH is 2.38. So first thing we should do is write out how our methanoic acid is going to ionize. So when it ionizes, it's going to do something like this. And because it's a weak acid, it is making an equilibrium. We know those weak acids make an equilibrium between the acid in solution and the ions in solution. So I like to track my givens a certain way here. So I'm going to write the concentrations under things as I solve for them. So right now we know from our problem that we have a concentration for the methanoic acid of 0.10 mole per liter. And to move forward with this, to calculate percent ionization, we need to know the concentration of our hydrogen ion. So the next thing we're going to do, we're going to calculate the concentration of that ion using our pH information. So we use that formula we learned in our pH lesson, and we get the hydrogen ion concentration is 4.2 times 10 to the negative 3. So just a little reminder, again, there's 2 decimal points here, so we're allowed 2 significant digits here. So now we can take this number, concentration of hydrogen ion, and it can come up here into our givens. So the next step is going to be to take these 2 concentrations and calculate our percent ionization. So to do that, we write our formula. P percent ionization, concentration of hydrogen ion divided by concentration of the acid times 100%. We substitute in our values and we solve to get P equals 4.2%. So then we can finish off with our therefore statement. So that's the end of this video lesson. I'm going to post some practice for you to try this as well. This is really a stepping point. We're going to start using percent ionization to get an initial concentration of hydrogen ions in a weak acid or basic solution that we then have to put into an ice table. So this is another one of those small pieces of the puzzle that over the next couple days, everything will kind of come together, and we will need to use all of these skills to solve for some equilibrium concentrations of weak acidic and basic solutions. So that's all for now.